Um, this is the second part of this chapter or this topic about equivalent system of forces. So, ang first part was about one, uh, moment of a force about a point. Now, for this one, let us start with this one. Moment of a couple. So, two forces F and negative F having the same magnitude, parallel lines of action, and opposite sense are said to form a couple, as shown in figure 3.5. This one. So, equal in magnitude, negative F lang eh, kay positive F kay first quadrant na. So, third quadrant na siya paingon. Negative F siya. But they are equal. The magnitude are the same. Parallel lines of action and then opposite in direction, opposite sense. Couple na siya. Clearly, the sum of the components of the two forces in any direction is zero. Bale, if you want to get the x component of this force, equal na sa nasa x component ani na force. Directed to the right, directed to the left. Also with y. Y component is directed upward for this one, directed downward. Equal sa din magnitude, so mag-cancel out lang. So ang sum sa components of the two forces is always equal to zero. The sum of the moments of the two forces about a given point, however, is not zero. So ang components lang ang ma-zero, pero ang moment dili man zero. So, while the two forces will not translate the body on which they act, they will tend to make it rotate. So dili gid siya equilibrium, no? There is no translation kay equal man ang components pero there is rotation. Mo-rotate siya. And the moment of the couple is equal to force times distance. So what you'll do is to get the perpendicular distance between the two forces. This one. And ang direction niya, same lang, clockwise or counterclockwise. So you try to analyze, asa siya mo rotate, counterclockwise ba or clockwise. And then we also have equivalent couples. So here's a sample one, illustration. As we can see, the only motion a couple can impart to a rigid body is a rotation. Mao lang na siya. Rotation ra. There's no translation kaya mag-cancel out lang man. Since each of the three couples shown has the same moment, magnitude, and direction equal to 120, we can expect the three couples to have the same effect on the box. So, meaning this couple is equivalent to this couple and equivalent to this couple. Same naman niyang effect. So, ang magnitude niya is 120, 20 times 6. So, diri siya mo-rotate siya y-axis and clockwise, counterclockwise siya with respect to y-axis. Same also with this. Magnitude is 120, 30 times 4. And then mo-rotate siya y-axis. Counterclockwise also. And also with this. So, equal in magnitude, same po o direction. Okay, equivalent couples ang tawag. So, next is we are going to use our knowledge about couple in resolving a given force into a force at O and a couple. So, finding equivalent system of forces. Okay. Consider a force F acting on a rigid body at a point A, this one, defined by the position vector R, figure 3.6a. While we can move F along its line of action, this one, kung mali ang line of action, pwede na to i-transfer ang F along its line of action. Naana siya sa principle of transmissibility. No changes sa equilibrium condition, basta kay same line of action mo i-transfer. But we cannot move it to a point O. I mean, we cannot move it to a point O which does not lie on the original line of action without modifying the action of F on the rigid body. So, the conditions of equilibrium will change na if i-transfer nimo ang F to another point, not on its line of action. So, kung i-transfer nimo siya sa point O, lahi na siya nga condition. Di na same aning original na system. So, sa center na figure is, originally, ang force is at A, di ba? Now, you want to transfer F to another point O. So, considering the two forces, kani sa landuha, dili man equal dire sa left. Kay dire sa left, isa lang ka force dire, F. Dire, duha na. Kay i-transfer man nimo ang F sa point O. So, para ma-equal ang left o kining center, what you will do is, i-counter nimo og same magnitude aning F. I-counter para, in effect, zero na silang duha. So, you try to change something, but in effect, walay change na nahitabo. Same sa, Same sa completing the square. Sa completing the square, given kag second degree term and the first degree term sa equation, if you want to make it a complete square, mag-add kag constant. Now, so kung mag-add kag constant sa left side sa equation, mag-add ka og the same amount or the same value sa right side para in effect zero lagi hapon, ba? Gimodify nimo pero as if na wala hapon nag-change siya. So mo ni ang nahitabo. Gi-transfer nimo ang force from A to O. I mean, you want to transfer F there is a point O. Pero at bangan sa nimo og F, so in effect, zero ni siya. Pero the result is kining original na force sa A and then this one ni form siya og couple. So we can replace this one by this moment about O. So kining couple, kining duha ka forces, i-replace na to aning M sub O. And then nadayintay F sa A. So mo na ni atong new na equivalent system. This is the original system and mo siya ang new or the equivalent system. So okay, mo na siya dayon. Therefore, any force F acting on a rigid body can be moved to an arbitrary point O, provided that a couple is added whose moment is equal to the moment of F about O. So, kini nga force F, pwede nimo i-transfer sa bisan asa na point provided na mag-add ka og moment. Okay. So, mo ni ang modification na mahitabo. I-transfer nimo sa lahi na point, mag-add ka og moment. Ang value ani is equal to force times distance. The moment of force F about point O. Mao ni siya. Okay? So, okay. Sample problem. First problem. A plate in the shape of a parallelogram is acted upon by two couples. Okay. Determine, letter A, determine the moment of the couple formed by the two 21-pound forces. Letter B, determine the perpendicular distance between the 12-pound forces if the resultant of the two couples is 0. And then letter C, determine the value of alpha if the resultant couple is 72 pound-inch clockwise and D is equal to 42 inches. Okay. Letter A is find the moment of this couple, 21 pounds. Now, Okay. This one. Okay. Letter A. Determine the moment of the couple formed by the two 21-pound forces. So, since the two forces or the couple, ang direction sa or ang line of action sa 21-pound forces is horizontal, therefore its perpendicular distance is vertical and it is equal to 16. So, positive force times distance. Positive siya because if you try to analyze ang direction ani nga couple, ang movement sa couple is counterclockwise. Ang direction niya ba counterclockwise. Mo na positive di siya. So, i-multiply mo na 21 and 16. Okay. Ang direction niya is counterclockwise. Okay. Letter B. Sa letter B is determine the perpendicular distance between the 12-pound forces if the resultant of the two couples is 0. Take note that the resultant is 0. So, let X be the perpendicular distance between the 12-pound couple. Okay. Kani. Perpendicular no 90 degrees. 90 degrees. Now, okay. The resultant couple is i-add ni Manimuha. Okay. Now, the moment of this couple, 12 and X, is clockwise. If we try to analyze, ang direction niya ni is clockwise. So, negative. Ba? And the resultant moment is the moment of the 21-pound couple plus the moment of the 12-pound couple. And 0 doon siya. Okay? Based sa condition, 0 na siya. So, i-add mo, ang moment sa 21 na couple is 336 and then this one, 12 na couple. Na kay X na 28 inches. Okay. Letter C. Find alpha. Okay, letter C is determine the value of alpha if the resultant couple is 72 pound inch clockwise and given ang D 42 inches. Now, the resultant moment is negative 22. Tapos D is 42. Now, for letter C, okay, for letter C, unknown pa ni siya. Unknown na. Dili ni siya ang 28 because X equal to 28 is based on the condition that the resultant moment is 0. For letter C, the resultant moment is negative 72. Kay clockwise man, no? 72 pound inch clockwise, so negative siya. Mo ni ang resultant moment. Therefore, you cannot use X equal to 28. Kaya ang resultant moment na 0 man. So for letter C, ano ang gini sa X? And based on nga triangle, X is equal to D sine alpha. Okay? We have this one. Resultant moment, moment sa 21 plus moment sa 12 equals resultant moment na negative 72. So, ang moment sa 21, mao na gini siya. We can no longer change this one because specified na madaan ang iyang distance. So, 21 times 16 na siya daan. Dili. 336. Ang moment sa 12 lang is 12 times kanya distance. Anon pabali ng X? We cannot use 28. Ha? So, kanina distance is D sine alpha. Kana. So, mo na atong perpendicular distance sa 12. So, inani siya. 336 sa M21 minus kay clockwise man minus force niya distance na yun. 42 sine alpha. Resultant moment na yun niya negative 72. So, to solve for alpha, you can transpose 336 sa right. It becomes negative. So, negative 72 minus 336 and then i-divide ni mo ng negative 12 After that, i-divide nimo ning 42 and then get the inverse sign. Okay. Arc sine sa value mo na ang alpha. And the value is 54.05 degrees. Another problem. The tension in the cable attached to the end C of an adjustable boom EBC is 560 pounds. Replace the force exerted by the cable at C with an equivalent force couple system at A and B. Okay. So equivalent force couple system, same atong resolution of a force no na. If you want to transfer a force, it will become a force and mag-add ka og moment. Same ra po daan eh. So we will make an equivalent force couple system at A. So we're going to transfer this force sa A and then determine the moment. And also sa B. Transfer na to sa B, nanatay force sa B. Moment na lang dayon. We get the moment of this force about B. Sige. So letter A, replace the force exerted by the cable at C with an equivalent force couple system at A. Okay. So, ato ni i-transfer sa C. Same sa illustration ko ganina on how to resolve a force into a force or any couple. So, i-transfer na to dito sa A. Okay. 560 na. Given mo na, no? 560 pounds. And then, so that remember, this is the original system and i-try na to o modify. No? So, ibali na to, i-transfer na to ang force sa A. Oh, and as you can see, dili man ni siya same sa original na system. Kaya ang original na system, isa ramang ka-force. Karon duha na. So, para same lang gyapon sa original system, apply na to og force opposite ani ana. So in effect, kining duha ka forces makancel ra man na. So walay kwenta ni no? So same lang gyapon sa original na system. Pero what happens is kini nga force and this one form a couple. So wow na to ang moment sa couple. Therefore, we have to find the perpendicular distance between these two forces. Kuha na to ang perpendicular distance para makuha na to ang moment nila, moment sa couple. So what we will do is extend na to ini nga line and then draw ta og line na perpendicular. So kana draw rin tag line. Okay. Mao ni atong perpendicular na distance. Okay. So how do we solve for D? Okay. So you have to construct a triangle. Nanam the triangle? 1, 2, and 3. Given na tao hypotenuse, 18, kulang na lang taog angle. Now, base there, the direction of T from the horizontal is 20. And since parallel na sila, 20 said niyo. Same rin na din sa baba. 20, 20 said na. So, ang angle ani is 50. Now, we can solve for D. From trigonometry, 50 nga angle, opposite side, hypotenuse. So, D is hypotenuse sine of the angle. So, that's 18 sine of 50. So, muna ito equivalent nga force couple system. Naantay force, 560 pounds. Direction niya is 20 degrees, fourth quadrant. Tapos, ang moment niya is force 560 times distance. Force times distance. Negative siya because it is obvious na clockwise ang direction. And mo na yung final value. 7,721.73 pounds feet clockwise kay negative. So, mao ni siya ang equivalent system sa A at A. Equivalent system ani na original na system. Letter B. Replace the force exerted by the cable at C with an equivalent force couple system at B. Okay. So, dili natin i-transfer sa B. Okay. 560 and then apply ka opposite na force. So, ang force sa C is now transferred sa B. But then these two forces, this one and 2, form a couple. So again, to get the moment, let's find the perpendicular distance. So extend again, and then draw a line ni perpendicular, mo na itong D. Na, base dire, kung 50 ni 50 sa ni. Same raman na, no? Kaya kung 4 sa A, parallel ani. So kung 50 ni, this one, 50 sa din. So we can solve for D. 10 yang hypotenuse. So D is 10 sine 50. So ang force couple niya is, ang force is very easy. Same lang na yan. 560. Ang moment na yun. Clockwise yapon. So negative. Force na times distance. Okay. And the answer is this. So from an original system of a force acting at C, nasa equivalent system at A, force and moment, nasa ta equivalent system at B, force and moment. Kaya lang, no? Another problem. A 60-pound force P is applied at point A of a structural member. Okay. Replace P with an equivalent force couple system at C. Okay. Similar sa previous na problem. But for letter B, replace P with an equivalent system consisting of a vertical force at B and a second force at D. Okay. So let us start with letter A. Letter A is replace P with an equivalent force couple system at C. So what we will do is, let's transfer P sa point C. 160 ang magnitude, ha? So, okay. Transfer na to. So, dili mo ni siya equal sa original. So, apply to opposite na force. Para in effect, 0 rin silang dalawa. Pero ang result is, the original force P at A and this force form a couple. So again, let's find the perpendicular distance. So extend na to. By the way, muna ni ang force, ha? You will not have a problem pag determine sa force kay same lang muna siya sa original. 160 angle of 60 degrees. Okay. So we'll get the perpendicular distance between the two forces nga nag-form og couple. Okay. So dito ka mag-draw og line sa tail sa isa ka force, this one. Dihaga. So that you can construct a triangle. So nakani nga perpendicular line and also this one, mao ni mo third side sa triangle. Kana. So distance from A to C. And then another yung right angle. Okay. So to solve for D, first we need to solve for DAC as well as this angle. Para mo gamit dayon ta ani nga D is equal to DAC sine of theta. So kana, we'll get this angle. What's the value of this? Okay. Sige. You have to use your background knowledge sa trigonometry. Now, to solve for DAC, You can make use of this right triangle. 1, 2, and 3. So hypotenuse, ang legs niya 4 and 2.75. Muna itong DEC. No? And the value is 4.854. Okay. Next, for this right triangle, you can solve any interior angle. Okay, this one. Let's denote this one as theta. You can solve for theta. You can use arctangent. No? Given opposite side 2.75, adjacent of 4, you can solve for theta. And it's equal to 34.51. Okay. We already have the value of theta. Next is, how do we solve this one, or how do we get the value of this angle? Okay. Let's make use of the given one. 60 degrees man eh. So therefore, kanisang angle 60 sen eh. Para equal naman eh 60, 60. 60 sen na. So kung 60 ni, kining angle is 120. Okay, 180 man itanan. So kana is 120. So considering this right triangle, oblique triangle rather, 1, 2, and 3. Given ang duha ka angles, 34.51 and 120. So you can solve for this third angle. It's 180 minus 120 minus theta. And the value is 25.49. So therefore, masolve na nimo ang D. That's DEC sine of 25.49. And naman tayo DEC na 4.854. Mo ni ang value. 4.854 sine of 25.49, 2.089. Makuha na to ang moment. So, moment is 160 times D, 2.089. And the value is 334.24 pounds feet counterclockwise. Obvious mo ano nga, mo-rotate siya about C counterclockwise. Or para if in case mo confuse ka, you can transfer this force speed dire by principle of transmissibility transfer. So that it will be easier for you to determine kung unsa ay rotation. So nakay P diha, mo rotate na siya sa C, dire na siya. Counterclockwise. So our equivalent system at C consists of this one, FC, and moment sa C. So to summarize, this is our original system, and the equivalent system at C is this. So kinibali siya nga system, equivalent ra na siya ani. Same magnitude sa force na mo din na yung moment. 334.24 counterclockwise. Okay. For letter B, replace P with an equivalent system consisting of a vertical force at B and a second force at D. Now, the problem here is wala tayo idea about this vertical force at B, whether upward ba or downward. And also sa second force sa D. Wala siya takabalo. Asa na quadrant? First ba, second, third, or fourth. So we just have to assume. So for the vertical force at B, let's assume na upward siya. Okay, review siya as our basis. The equivalent force composite system at C is this one, force at C and then moment at C. Because this will be our basis na dayon sa letter B. Na dapat, kini na system sa letter B, same also with this system. Kay kanina system, equivalent man ni ani na system. Okay? Sige. So the vertical force at B, let's assume na upward. Let's assume na positive sa nga direksyon, na upward. And then the second force at D, wala man specify kung upward ba siya or downward or vertical lang saan. Not like sa B na vertical good. Ang second force sa D, inclined. So mag-assume lang ta na first quadrant. Anyway, pag mag-negative siya, and then ato ra i-change sa final na answer. Okay, D, FD, and then angle theta. Ano, no? Direction niya. Or, we can change this one. Instead na magnitude and direction, we'll replace this one by its components. So, FDX and FDY. So, focus sa green nga color. We have three unknowns. FB, FDX, and FDY. Okay, forget about the blue color. Green silent. Three unknowns. So, bale, kini na system nga green must be equivalent to this system, equivalent also to the original na system. Sige, equivalent ha? Okay, so let's resolve this force. That's 80. Yun sa pagkuha ng 80, P is 160. 160 cosine of 60, that's 80. And then on vertical, 160 sine of 60 is 138.56. So kung may nga equivalent, dapat kining pink or kining black equivalent sa green. So let us start with summation of 4 sa x. Okay. By the way, if you want to resolve this for same ra din, 80 rasad and if component sa y was 38.56. So, sige. Let's compare na lang black and green. Forget about pink lang. Okay, anyway, para lang manin natin basis sa FCX and FCY. Okay. I-compare na to ang green o black. So, let's sa mga 4 sa x. Kung sa mga x dire, kani 80, no? Sa green, f dx. So, equal na sila. Kini na force, atong i-compare ang equivalent system sa C o kini nga sistema, i-compare na to. So, since ang x component sa FC is 80, dapat 80 sa ni, wala may lang x component. Okay. So, f dx is equal to 80. Now, summation of force sa y. Ang y sa black equal sa y sa green. So, 138.56 is equal to FB and plus FDY. Third, tulo mong ka-unknowns. Summation of moment. Sa C ka mag-moment. Nganong sa C man? Because ato man i-compare ang green sa black. Ang sa black ay moment sa C man. So sa C po ka mag-moment sa green. Okay, dapat equal man sila. Para same atong basis. Kay kining black, referred man sa C. Moment about C man. So kaning green, ato sa siyang kuhaan og moment about C. O ang total na equal ani 334.24. Counterclockwise. So inaani siya. Muna siya ang moment sa muna ang value sa black. O ang sa green dayon, if dy raman ang counterclockwise, if dy times distance of 4. Counterclockwise na. Kay dili mo siya ma-rotate. While ang if dx, clockwise na siya. Force times distance. Kana. Ang FB sad clockwise yapon. Dili siya ma-rotate sa C. Force times distance 2. Okay. So we have 3 equations with 3 unknowns. Pero Na naman tayo value sa FDX. That's 80. So what you will do is, i-transpose nini mo sa left side. Ma-positive na siya, kaya negative man eh. Ma-positive na siya. 334.24 plus 80 times 1.25 equals this one. Okay. So instead na 3 equations, 3 unknowns, 2 equations, 2 unknowns na lang. This one, summation of force sa y, okay, ni summation of moment. You can use your calculator kung kung capable siya mo solve. If not, use method of eliminations. Okay. So after using method of elimination, pwede na ito ma-solve ni. FB is positive, positive 20. Therefore, our assumed direction is correct. And FDY, positive pod. So, ang atong assume nga direction, correct sad. So, okay. So, since we now have the values of the components, pwede na tayo makuha sa magnitude and direction. So, magnitude 143.03. Direction is arctan of Fy over Fx, 56 degrees. Okay. So remember, FB is 20, FD is 143.03 at an angle of 56 degrees. So, ang equivalent force composite system na to for letter B is natay FB na 20 upward, and natay FD na kini. 143.03, angle of 56 degrees. So to summarize, this is our original system. Another equivalent system aside sa C is this one. Natay FB na 20, natay FD na angle of 56. So kini nga system is equivalent to this original na system. Okay, so that's it. I hope that you have learned something from this one. Mao ni sa ang kwan, mao ni sa ang equivalent sa finding resultant sa particle ba. Equivalent system of forces. Original system i-replace na to og another na system. Okay. Thank you for watching.